Hello and welcome back to Getting Started with BGFX. So in this video we are going to do depth testing, alpha blending and stencil. Now alpha blending is all about determining how transparent or see-through that particular pixel is so that we can see some objects behind it. This is useful for things like windows or stained glass or water, anything where it's transparent and we can see objects behind it. Now the depth testing is all about determining which objects are in front of which, and in our frame buffer that we created in the last video, it has a depth stencil attachment. Now each pixel has its own depth value, and in BGFX by default it gets cleared to 1, and if there is a pixel that has a lower depth value, so maybe 0 or 0.9 or anything that's less than the value that's already there, that test passes and we can see that pixel. Now we can change the test, but by default it's always less. So if the depth value that's coming in from a shape is less than what's already there, then we can see that pixel. Now the stencil is similar but different. It's not about what we can determine what is in front or behind or whatever. It's all about whether or not we can see that pixel at all, whether or not that color is going to be turned on or off. And the same thing, we can enable testing. We can write a value to the stencil buffer. We can test it to see if that particular the stencil value for that pixel has a value, and if it does, then great, then we can render that particular color. If not, then we don't. What this is useful for and what we are going to use is a shape outline. So we're going to have two quads. We're going to have a larger quad and a smaller quad, and the smaller quad is going to cut the middle out of the bigger quad so that we can do an outline. Alright, so without further ado, let's dive into the code. So if we go into our project and we'll go into the main code, we'll get rid of the quad that's already there, and we'll do two quads here. We'll do draw quad, put this at negative 550.0f, 0.0f, no rotation. So we'll make this yellow, so this is the alpha, so make it completely opaque. We have no blue, we have full green and full red, and we'll set the scale to 111, so this will be normal sized, and we'll do the same and we'll do another quad. This time it's going to be at negative 500, and we'll make this purple. So we'll run that. And as you can see, the yellow square appears on top. This is because the depth for all of these pixels is cleared to 1.0. And then the yellow square is drawn first, which has a depth of 0. This passes the depth test because it is less than the current value. And then the purple square gets drawn, but the depth of the pixels that overlap the yellow square are already 0, and therefore it is not less. Therefore the depth values from the purple are 0, and they are not less than the values that are already there, so the test fails. Now if we go back to the code and we change the depth of the yellow to 0.1, we can see now that the purple is drawn on top. That's because the depth of the yellow pixels that overlap are 0.1, which is not less than the depth value from the purple square, which is 0. Alright, so what we're going to do now is we are going to enable alpha blending. That was the depth testing. So to enable alpha blending, we'll need to go into our renderer, and we'll go down to our render function. Inside the render batch loop, we need to set the state. We go BGFX : set state, open bracket. We'll go BGFX state underscore right. BGFX underscore state underscore right RGB. Then we need to OR it with the other values. So we'll enable the alpha blend, blend underscore alpha. We need to write to the Z value. So we'll go BGFX underscore state underscore right underscore Z. Oops, need to OR it, not a comma. So writing to the Z, that's just writes to the writes to the Z. So that's to enable the depth, and then we will set the tell BGFX how we want to test the depth value. So depth test less means that if the depth that's coming in from the shape is less than what's already there, then the test passes. We need to do this inside of our render batch loop because the state resets to the default when we submit anything to draw. Okay, so let's turn down the alpha blending. So let's turn down the opacity of both of our shapes. Turn down to 7.7, which is about half opacity. Then we run it. And you can see where they overlap, it's blending nicely. However, depth testing and alpha blending do not play nicely with each other. If we set the depth of the purple to 0.2, we can see that there is no blending at all. That's because the depth fails. So the depth of the purple is, well, the depth of the yellow is 0.1, so that gets drawn first along with the alpha. But the purple comes along with a depth of 0.2, that fails, so no alpha blending is done. The way to solve this is to sort the draw calls so that the purple square gets drawn first and then the yellow on top of it. Depth testing does not do this, so we have to do it ourselves. Fortunately, the submit function in BGFX allows for this. So if we go into our renderer header file, we go down to our render batch and we'll put another value for depth. Now we need to change our function so that it has another parameter for depth. Do it for both of these. And then we go to inside those functions. Do the draw quad first. Then we'll set the depth for the batch. Do the same thing for here. And then we set the depth in the submit. So depth, yep. And then we need to disable the depth testing so that it doesn't interfere. So we'll get rid of the depth test less. And now we'll go back to the main code and we'll set the depth for each of our squares. By default, the draw calls are sorted by depth in ascending order. So we'll set the depth of the yellow to 0, set the depth of the purple to 1, and we'll set the depth of the image to 0. We'll run it. And as you can see now, it is blending nicely. And if we change the order of it, maybe change that to a 2. And you can see now, drawn very nicely, still blending no matter which way we go. It is a slightly different color. That's because our purple is transparent. But if we turn off the opacity, make it completely opaque, see, some nice alpha blending there. And if we set the yellow back to 0, and you can see the purple gets drawn on top. That's what we expect because the depth for the yellow is 0 and the depth for the purple is 1, so the purple gets drawn on top and it's completely opaque, so no transparency whatsoever. Alright, so finally what we're going to do in this video is we are going to do the stencil. Stenciling is used to cut bits out of shapes, and it is controlled at the pixel level, so we can get very precise shapes. So in our example, we are going to set up 2 squares. So we'll do it after the image. We'll do renderer dot draw quads. Put this at 500 and 0, 0. No rotation. And we'll make this a, we'll do this a purple shape, so 0xFF, so that's the alpha, this is the green, no sorry, that's the blue, this is the green, this is the red. And we will not scale it, we'll keep it at normal size, but we are going to draw another shape directly on top of it. This one's going to be yellow, and it is going to be slightly larger. And just to show you that this does work, we'll set the depth to 0 so that they are drawn at the same depth, and the yellow, as you can see, is drawn on top. So how stenciling works is we clear the stencil value for each of the pixels, which BGFX already does through setting the view clear function. Then we tell BGFX to write a value to the stencil buffer for every pixel that we can see. And then we test the stencil buffer for every pixel that passes the stencil test. Then we test the stencil buffer, and every pixel that passes the stencil test gets rendered to the screen. Every pixel that fails gets discarded. So how this would work is that the outline of this yellow square would be rendered, but the inner part of it would fail. So we will see the purple square. Alright, so let's implement this in our renderer. First, we are going to create a new variable inside of our renderer. This needs to be in the renderer itself, and we'll go uint32_t m_stencil. And then we'll do the same thing inside the render batch. Stencil. And then inside our draw functions, we will set the stencil value in the batch to what it is in the renderer. So we need to do this for each of the draw functions. So we'll go batch.stencil equals m_stencil. We can just copy that for the image. Alright, now inside our render batch loop, we need to set the stencil. So we'll go BGFX, set stencil, and we'll set it to the batch.stencil. Alright, now we will create a function to tell BGFX to always write to the stencil. So we'll go back to the renderer and we'll create another function. We'll call this write to stencil. And we'll create it. And we'll go m underscore stencil equals BGFX underscore stencil underscore op underscore fail underscore s underscore keep. Then we OR it with BGFX underscore stencil underscore op underscore fail underscore z underscore keep. And then we OR it with BGFX underscore stencil underscore op underscore pass underscore z underscore replace. And then we OR it with BGFX underscore stencil underscore test underscore always, and then we OR it with BGFX underscore stencil underscore func underscore ref 1, and then we also OR that with BGFX underscore stencil underscore func underscore rmask, and we'll set this to 0xff. Cool. So what this will do is that it will tell BGFX that if the stencil test fails, then keep the current value. If the depth testing fails, keep the current value. If the depth testing passes, then replace the value. This part tells BGFX to always write this value to the stencil buffer using this mask. Now this mask is ANDed with the value here, and the result is put into the stencil buffer. In this case, the whole value is written to the stencil buffer. So when we write to the stencil, we'll always write to this value. And now what we need to do is we need to create another function which will enable the stencil test. So enable stencil test. And we need to, we'll start this again. We'll go m underscore stencil equals BGFX underscore stencil underscore op underscore fail underscore s underscore keep. OR it with the fail z keep. And then we'll OR it with the stencil op pass z replace, and then we'll go BGFX underscore stencil underscore test underscore not equal. And you can see here in this code complete we've got all sorts of tests. We're just going to stick with the not equal, and then we'll OR it with all that. So this is the same as the previous function, except we are enabling the not equal stencil test. This means that if the stencil value for that pixel is equal to 1, then discard it. If it's not equal to 1, which is the value in here that's been ANDed with this mask, then it will be kept. So now finally we create a function to disable the stencil. So we go void disable stencil. And inside here we just go, so you can see it, there you go. M underscore stencil equals BGFX underscore stencil underscore none. Here we go. Alright, now let's go use our new functions. So first thing to do is we are going to write to our write to the stencil. So we go renderer dot write to stencil, and then we'll enable the stencil test. And then finally, after all that's done, we disable the stencil. Alright, now we'll run that. And as you can see, we have now cut out the middle of this yellow square. So what happens is that when the purple square gets drawn, it will write the stencil value of 1 to each of the pixels, and then the yellow square gets drawn. We enable the stencil test, and it finds that all these pixels around here do not equal 1. They are initialized to 0, and therefore that passes the stencil test, and so they are drawn. But the ones in the middle have a stencil value of 1. So because of the test that we told it to, that means that the stencil test fails and they won't be drawn. And that's it for this video. I will push everything to GitHub. In the next video, we are going to be going 3D, and we'll be making a rotating colored pyramid. So I'll see you in the next video.